Hey guys, welcome back. Today we're going to be looking at transformations of functions. For this case, it would be linear functions. Now here in Algebra 1, we're going to be in Algebra 1, and you're going to be depending on if you're in Algebra 1 or Algebra 2, this would be great preparation for the next lesson that you might want to watch, which would be on absolute value functions. Because absolute value functions are all about transformations of graphs, unlike linear equations. So this is just going to give you an introduction to the many different types of transformations that we can do to functions. Now, if you remember back in middle school or geometry class, whatever, when you learned about different transformations of geometric figures in a coordinate plane, which included translations, selections, rotations, vertical stretches, and shrinks. We're going to be doing something similar to that. But there are a few differences between functions and geometric figures, and so let's give it a try. All right, so you might notice already that a translation is a shift of a figure it can be up, down, left, or right. Now I'm going to give you a horizontal translation. I'll give you the horizontal translation rule. So, horizontal translation can be anything in the form. You can go from this simple function f of x. Is there an arrow button here? Oh, there it is. It can go into something like this. H is, no, I don't want uppercase. H is the number of units the graph moves in a horizontal direction. So let's go to the graph. So we're going to do y equals x. So this is the very basic function of linear function that you will ever get. That's called a parent function. Now, family of functions is simply the same kind of function, but has different values added to it to give some unique qualities. And all this really has is slope of 1, y-intercept of 0. Now, what if we try to shift it to the right 1 unit? Then we could write the function like this. Really, we don't need the parentheses. And so we are not moving to the left 1 unit, we are moving to the right. Remember, there's a negative sign already there. If it was a positive sign, then we would be moving to the left. Anyways, slope doesn't change. Y-intercept changes, x-intercept changes. We generally move 1 unit to the right. And then that's how we draw. Until this dark line right here represents y equals x minus 1. Horizontal translation 1 unit to the right. Unit to the right. Now, why don't we try something like this? Now why don't we try something like this? How about y equals 2x? This might get a little bit more complex. Alright, so let's say I wanted to move 2 units to the right. Then we will write the function as like this, and then substitute x for x minus 2. Use the distributive property to simplify, we get 2x minus 4. More. So this is our general function here. And then the horizontal translation would be right here. And then connect to the y-intercept. Let's try. Boom. A little curved, but whatever. I'm terrible at drawing on my computer, guys. Technology just flat out sucks. But anyways, enough with technology issues. Try this one. See if you get what does. Remember that this is our basic function. Now plot its translation. Okay, so we are gonna try and draw this. We're gonna simplify this, find the y-intercept. 2x, 2 times 2 is 4. So there's y-intercept at 4. Translation 2 units to the left, because it's a positive sign. And then connect the points. Pretty simple, right? Yeah. Now, alright. But guess what? Horizontal translations are still not the easiest. I just mistakenly did horizontal translations first. Vertical translations are what make functions go up and down. So they look something like this. F of x turns into f of x plus k. And yes, we have an addition sign here. So a positive k value would mean units up, negative k value would mean units down. Okay, so let's say we go back to this again. We're going to draw its parent, the base, draw it. Alright, so now let's consider what happens if we try to translate it up one unit. Equals x plus 1. Really, that's all. See what I mean by vertical translations are easier to understand than horizontal translations? And why I said I made a mistake there? Yep, I sure did. I messed up. But you know what? Yeah. Anyways, let's say you try something like this. Try translating it 2 units down. So I'm going to draw the function for you. Alright, so why don't you try and write its translation equation for 2 units down, and then graph. Alright, so you should have got y equals x plus 1 really you just need to subtract 2, and then this turns into y equals x minus 1. And guess what? This is the third time I had to draw this exact same line. Check out my previous video on linear functions. Not functions and graphing them. I accidentally used the same equation twice. I don't know how I managed to do it, but it's just silly. Oh dear, I still can't get over it. It only happened like half an hour ago, so. Anyways, we're going to talk about reflections now. So, there's a reflection over the x-axis and a reflection over the y-axis. I'm going to be smart and do reflections over the x-axis this time. So, we can be saying that f of x, where's my arrow? There we are. Turns into negative f of x. Alright, so that's it. Really? Oh, yes. I forgot that I was still processing a video. Okay, what am I doing? No, I'm not copying equations intentionally. I'm literally just trying to get an idea of what I should be talking about. Okay? Don't worry. Anyways, let's say we have this very basic one again. Alright. I don't think that's a wise idea, actually. How about x plus 1? That would give a little bit more of a challenge. Yeah. And so, a reflection over the x-axis means that we have to multiply everything here by negative 1. So, if we multiply everything by negative 1, we should have y equals negative x minus 1. So, notice that in my original function, it was 1 unit above, the y-intercept was 1 unit above the origin. Now, with the reflection over the x-axis, it's going to be 1 over the y-origin. X-intercepts stay the same though. And would you look at that? We got ourselves some perpendicular lines. We're going to talk about those soon. Alright. I just like having fun, guys. Alright. Alright. Why don't you try writing a reflection of this, 2x minus 1. Pause the video, write its reflection equation, x-axis, come back when you're finished. Okay. Remember, multiply everything here by negative 1. You should have y equals negative 2x. Negative 1 times negative 1 is positive 1. I'm going to graph the original equation because I forgot to do so. I just like doing it, that's all. And then yep, I love this. I just love this. Okay, not all the time are. You know what? That actually does not make any sense. That's a terrible line, Anthony. Terrible line. Really, it's supposed to intersect like right here, but apparently I missed that. They are supposed to have shared x-intercepts. I just messed up that time. Alright? Alright. Reflections over the y-axis. Now, we are going to do f of x, transform it into f of negative x. So this time we're not multiplying by the whole thing, we're just multiplying the x term by negative 1. So let's say you have this again. Really, we just need to make make x negative. And then we have negative x plus 1. So the y-intercept does not change. Change because we're reflecting over the y-axis. Axis. And they're supposed to be perpendicular lines again. Oh darn, I can't finish my arrow. Okay, there we go. Okay. Don't worry guys, I'm almost done. I just got to get through horizontal and vertical stretches and shrinks after this. Alright, how about x minus 1? No, x minus 1. Oh, 2x minus 1 actually. That sounds better. Better. Graph of the equation. Right reflection over the y-axis and graph it. Go on, just go. Okay, here we go. Sorry, getting a little out of control. Anyways, we simply need to make x negative. Y equals 2 negative x minus 1. So this simply turns into negative 2x minus 1. So really guys, all we're doing here is doing the opposite of making the slope opposite of its original function. So the opposite of 2 is negative 2, opposite of negative 3 is 3. That's really what we're doing. Alright, 2 more rules. And 2 more rules. So, horizontal stretches and shrinks. No. Bad move. Vertical stretches and shrinks. Don't mind me. Sorry, I had to sneeze a little bit. Alright, so vertical stretches and shrinks. So, these ones you might not be familiar with. Really, all they are is all the points are stretching away from the x-axis or y-axis, in this case x-axis, by a certain factor. So, f of x would turn into a f of x. Alright, so a f of x. A is the factor at which the points are stretched. So here's a rule. Okay, so there is a little rule here. I'm going to use a bullet for this. If a is greater than 1, then the graph has a vertical stretch. And if 0 is less than a, and a is less than 1, then the graph has a vertical shrink, or when the points go towards the x-axis. Okay, where am I going? So let's try this. This is very simple because all we're really doing here is change the slope, guys. Alright, so let's say we want to do a vertical stretch of 2. So really we just need to add the coefficient to this. And then notice how spread out the points are from the x-axis now. Try vertical shrink. Try vertical shrink, see what happens. Let's try a harder one. Try vertical shrink, see what happens. Let's do y equal. So, what's a vertical shrink of 1/3? Write the equation out and graph it. Alright, so y equals 1/3 x. Alright, so now we're gonna go. Oh boy, that's pretty close, don't you think? Pretty close to the x-axis? Yeah. I love having fun with these videos, guys. I just love them. Alright, last rule, guys. This one is actually pretty tricky to understand. So there's horizontal stretches and shrinks. Horizontal stretches and and shrinks. So f of x turns into, you might think it's f of ax but that is correct. But that is but if a equals 2, that doesn't mean that this points get further from the y-axis. Yes, we are doing y-axis. Doing a stretch and shrink from the y-axis. However, there is a catch. If 1/a is greater than 1, then the graph has a horizontal shrink. Yes, reciprocals. That's a good catch you're going to want to pay attention to. Pay attention to. And then if 0, oh dear, if 0 is less than 1/a, which is less than 1, then the graph has a horizontal stretch. Okay, so let's try it out. Okay, so we're going to do y equals x plus 1, just to give a challenge. Alright, so we're going to graph equation. Alright, so let's say we want to do a horizontal stretch of a factor of 2. How do we write this out? We simply need to write its reciprocal. So we do y equals 1/2 x plus 1. X plus 1. 1. Ooh, one thing I forgot to mention. You would have had to use the y-intercept in my equations and you had to do a vertical stretch or shrink. You had to change this too. but we're not changing it for horizontal stretches and shrinks, okay? Okay, so 1/2 x plus 1. Okay, let's see if I can graph this well. So I might say that the factor is 2, which means that it is stretching away from the x-axis, or from the y-axis. Axis. But really, this number right here, is what represents your stretch when writing the equation. Okay, reciprocals, only reciprocals when talking about horizontal stretches and shrinks. But I've had enough teasing for now. I think I thrown a lot at you. It's, whoa, 26 minutes. Yikes. Oh dear. Well, I just threw a whole bunch of information at you again, but hopefully this gives you a good idea of what transformations of linear functions are. If you're an Algebra 2 student, you're going to be learning a lot about transformations of graphs. You're going to learn how to transform linear functions, absolute value functions, quadratic functions, polynomial functions, radical functions, exponential functions, logarithmic functions, maybe rational functions, and maybe trigonometric functions. Rational functions, trig functions are hard for transformations, so we're going to leave that up. Anyways, thank you so much for watching, guys. Please leave a like and subscribe to my channel for more videos. If you really like this video, please share it with your friends. I like to help out as many people as I can. Math is a pretty hard subject. Reminder, I'm going to be teaching math from Algebra 1 to AP Calculus AB, because that's the math class I'm going to be taking my senior year of high school next year. That would be AP Calculus. Anyways, thank you so much for watching, guys, and have an amazing rest of your day, for you cannot resist the evil of the thriller.